Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafitri Benuzaimi. My metric number is AA212145. Today I'm going to brief about the introduction. Transformer is a passive component that are used for transferring the electrical power from one electrical circuit to another circuit. This component is working by the concept of Faraday law of electromagnetic induction. These concepts are working which the primary coils will induce the voltage into the secondary coils by using the magnetic induction. This electromagnetic field was discovered by Michael Faraday in 1831 and Joseph Henry in 1832. Michael Faraday furthered his experiment until he found out about the equation that describing the relation between the electromotive force and the magnetic field. Back to the transformer, the change of current value between the primary coil and the secondary coil will help in increasing and decreasing the alternate current voltage in many electrical power applications. Transformer components can be categorized into two types, that is step 1 step up transformers and step down transformers. Nowadays, transformers are available in different sizes ranging from the cubic centimeters to hundreds of tons. That's all from me.
Mutual inductance occurs when two or more inductors' magnetic fluxes are connected, causing voltage to be induced in one coil proportionate to the rate of change current in other. If the number of the second inductor is double of the first inductor, so the power output or the voltage output will be double. So the winding on the inductance, the first and second, usually are different. So the function of transformers to transfer the current from the input, which is first inductance, to the output, which is second inductance.
Hello, my name is Ambassador Badner, and now I will talk about three important things of transformer. The first one is voltage ratio. The voltage ratio means voltage of the winding in the transformer is directly proportional to the number of turns on the coils. The ratio of primary voltage to secondary voltage is known as the voltage ratio, and voltage ratio is actually same with turn ratio, that is primary turns of wire to the secondary turns of wire. So we can use for equation that the voltage ratio is equal to the turn ratio. And then for the second one is current ratio. The current ratio is liquidity and efficiency ratio that measure a firm's ability to pay off its short-term liabilities, which is current assets. The current ratio is an important measure of liquidity because short-term liabilities are due within the next year. This means that a company has a limited amount of time in order to raise the funds to pay for these liabilities. Current assets like cash, cash equivalent, and marketable securities can easily convert into cash in the short term. For calculation for current ratio is current assets over current liabilities. The last one is transformer efficiency. The efficiency of transformer is introduced as the ratio of beneficial output power to the input one. The input and output power are detected in the same unit. Each unit is either in kilowatt or watt. And how to calculate the efficiency of transformer is by using value of power output over value of power input, and then multiply by 100. That's all for my presentation, and now I will pass it to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syaril Nizam bin Karis Fadilah, and today I will be present about transformer rating. The transformer rating was designed and invented based on current and voltage. and name voltage amps as the unit for transformer rating. It is built for the scientists to define about the losses of voltage and current. And transformer rating also can be called as maximum voltage and current voltage that suits the transformer. And the rating also depends on the temperature rising. With If the temperature rising, the temperature rating also losses. So the greater the effective of cooling temperature of a transformer, the greater the rating of the transformer rating. Next, there are two main type of losses that will be a main fact with the transformer rating of changes. First of all is constant losses. Constant losses depends on the V, on the losses on the V, which is voltage. And the second is the variable losses, which is depends on the I, and which is the current, and it depends on the losses of the current. Next, the losses of transformer rating depends upon the losses of V and I, as I stated before. So that shows why the transformer rating is all about in the unit of VA and kVA. Next, as as appear at the slide above, this is the example transformer circuit, and I will show the solution. And the solution for the transformer circuit, and we want to find about the loops for the secondary. We can use the formula, which is NS and secondary and equal to NP with Vs per Vp. So we can conclude the N secondary is, and we put in all the value such as 50, 100,000 per 120, and we can get the loops for the secondary N. And for the B, we can use Is per Ip equal to Np per Ns to find the current for secondary or primer. And we can find, and we can use it, we can put in the value that we want to use, so we can get. So that's all from me. Thank you very much.
We meet again, but now we are going to learn a little bit about the application of the transformer in the real world. Firstly, is the regulating alternative current, which is all transformers have the same main function, that is increasing and decreasing the alternating current, which is AC current that flow through it. By regulating the flow of current, the transformer will also able to increase the efficiency of the energy, which is regulates and reduces the electricity bills. Then we move the battery charging. The transformer inside the charger will be the guard to control the voltage that enters the battery during the charging process. The role of the transformer is very important, especially when the charging process is in progress. It is important for preventing any damage that can occur to the internal battery components. The risk can be happen because of unregulated voltage that produced inside the charger. For example, step-down transformer are used inside the mobile phone charger, but only a ferrite core transformer is used to operating at 100 of kilohertz or even few megahertz. Then we'll move to the use of the transporting the power supply from the power station to the whole city. It is the transport of power around the national grid start from the power station. Before the power leaves the power station, it will be raised into a high voltage using the step-up transformer until the voltage achieved around 275,000 volts. This is because more energy is dissipated to the surrounding through heating. To reduce the energy waste produced, higher voltage are needed to increase the current and also create a lower resistance inside the cable along the transporting process. When the current is already arrived at the houses or factory, the voltage needs to be lowered so that it is suitable for the electric appliances used in that place. That's all from me. Thank you.
For the conclusion of this experiment, we got to fulfill our objectives in this project. The objectives are: we are able to understand and describing the structure of the transformers. The second one, we learned and understood how the transformers work. Besides, we are able to explain about the mutual induction principles, such as the relationship between induction and the transformers. Moreover, we found some application of transformers in our daily life, and we made some calculation about the transformers. We know that transformer is widely and commonly used in electrical devices. And lastly, our main objectives for this project is fulfilled, is which we want to know more about transformers. That's all for us. Thank you.